Today we're going to continue our work with the equations and translations of equations of lines. So I have a couple of pages of notes for that. To show you an example, it would be a little bit like your homework. So we have several functions here. F of x is 3x plus 4, g of x is 1/2 x minus 8, h of x is 4 times the quantity x minus 1, and k of x equals minus 2x. Now this one's written in a different form than the rest. I would like to get it just in plain slope-intercept form. I'm going to go ahead and do that now. So I'm going to use the distributive property. 4 times x is 4x. 4 times negative 1 is negative 4. So I'm just going to use this when I need it later on. Okay, we have a new function, m of x. New function. It's defined as f of x translated down 5 units. So you need to think of it like this. M of x is means equals f of x translated down by 5. So you're going to start with f of x and you're going to move it down 5 units. So you're going to subtract 5 from all the values. This is called translation form. Translation form has your new function, the original function, and how much it is adjusted by. The next part is to write it in slope-intercept form. So I'm going to start with this right here. I'm going to write m of x, that's my function, and that equals f of x. So I'm going to write f of x, 3x plus 4. I like to put parentheses around it at this stage. And then I'm going to subtract 5. That's my translation down 5 units. Now I want it in slope-intercept form, so I'm going to combine these like terms right here. And I get mx equals 3x minus 5. That is my slope-intercept form. Slope-intercept form, translation form. Okay, next one. We have another new function, p of x. It is defined as g of x translated up by 3. So p of x is, which is an equal sign, g of x. So you start at g of x and then add 3 everywhere. So it's like g of x, a line, and then you're going to move it up by 3. This is translation form. So translation form is very easy to write. It's just two functions equal to each other plus whatever the translation is. And if we don't know how much it's translated, we would put a k there. Sometimes you're asked to figure out what k is equal to. Anyway, how would we write this in slope-intercept form? I'm going to start with this. P of x equals g of x. So g of x from the top here is 1/2 x minus 8. I like to put those in parentheses, and then plus 3. Now I need to combine like terms. So I get p of x equals 1/2 x minus 5. This is slope-intercept form. Slope-intercept form, translation form. Okay, we got another one. A new function r of x. Defined as h of x plus f of x. Write the new function in slope-intercept form. So r of x equals h of x. Where is h of x? Okay, I'm going to use my new version of that too. 4x minus 4 plus, you can put parentheses around that if you want, plus f of x, which was 3x plus 4. I like parentheses because it helps me see that I have both of my functions included. Now I need to combine like terms. So I'm going to combine these terms. Let's rewrite r of x again. 4x plus 3x is 7x. And then let's see the numeric part. Minus 4 plus 4 is 0. Usually we don't write a plus 0, so I'm just going to write this as r of x equals 7x. That is it. Alright, the next one. Which two functions are perpendicular and how do we know? Well, hopefully you're already thinking, well, perpendicular lines have opposite reciprocal slopes. So let's look for opposite reciprocal slopes. I got 3, 1/2, 4 and negative 2. So the only thing that could possibly work here is here, 1/2 and negative 2. Those are opposite reciprocals. So my perpendicular functions are g of x and k of x. And I like to write it, if they're perpendicular, I'm going to show it just like that, the perpendicular symbol. This says the function g of x is perpendicular to the function k of x. And how do I know? Because their slopes are opposite reciprocals. Alright. There's the only choices. There's no other that have opposite reciprocal slopes. Alright, we have another new function. Another new function has some information about it. U of x equals 2x minus 20. Write this as a translation of another function from the list above. Okay, so u of x is a whole new function, and it's a translation of one of these. Well, we know a translation has to have the same slope. So the slope I need is negative 2. The only other function with a slope of negative 2 is k of x. K of x is negative 2x. So basically what I know is u of x has to equal k of x plus some kind of translation, and we'll call it k. It's a coincidence that this k and that k match up. That really doesn't matter. But u of x equals k of x plus some adjustment k. So let's see what the adjustment k is. We need to figure that out. So u of x, I'm going to plug in minus 2x plus 20 equals k of x is minus 2x, and now we're going to put plus k. I need to figure out what k is. Alright, so what I'm going to do is I'm going to solve this equation for k. I know there's a couple of different variables in there now, but don't worry so much, because guess what? They're going to cancel. If I add 2x to both sides, all I get is 20 equals k. That's my vertical translation, positive 20. So, given that, I'm going to rewrite this. U of x equals k of x plus 20. Okay, let's try another one like that. The new function is given as wx equals 4x minus 10. Write this as a translation of one of the functions from up above. So I know the slope has to equal 4. So which function from up above had a slope of 4? It's going to be h of x, which was 4x minus 4. So I'm going to just write h of x equals 4x minus 4. That way I have it all down here where I can use it. And I'm going to use a similar technique that I use right there. I know w of x equals h of x plus some value k. I need to figure out what k is. So I'm going to plug in this over here. What do I know? Wx, instead of writing wx, I'm going to write 4x minus 10. Instead of writing h of x, I'm going to write 4x minus 4, and then bring down this plus k. That's what I'm trying to find out. I know I have a couple variables, but I'm not going to worry about it because they're going to cancel out. I know they're going to cancel out because the slopes are the same, so the slope term is the same in both cases. Let's subtract 4x from both sides. Leaves me with minus 10 equals minus 4 plus k. Let's add 4 to both sides. Minus 6 equals k. So my vertical translation is minus 6, which means down 6 units. Let's put all this together. Wx equals h of x minus 6. That's how that works. Okay, page 2 of the class notes looks like this. So we're continuing in, actually we're in task 8.5. You guys didn't get a packet this time, but these came from what the packet would have been. Writing functions in translation form. We'll see a couple of different ways to do this. So we're given information about two functions, f of x and g of x. We're actually given those equations here. We're going to rewrite g of x in translation form in this form. G of x equals f of x plus k, where k is the vertical translation. K may be positive and it may be negative. So here we go. I have f of x, 7x plus 13. I have g of x, which is 7x minus 5. So how do I get from g of x to f of x? And I need to write it in translation form. G of x equals f of x plus or minus k. So what is that? F of x, let's look at this. F of x, what do I need to do to get from f of x to g of x? These are exactly the same. So the question becomes, what do I need to do to get from 13 to negative 5? Should I add something from 13 or subtract something from 13? I should subtract. How much? Subtract 18. 13 minus 18 is negative 5. So the translation is g of x equals f of x minus 5. Simple as that. Here we go again. What's the translation of g of x? The translation of f of x to get to g of x. So g of x equals f of x plus or minus something. What do I do? These are the same. What do I do to get from negative 12 all the way up to 13? 213. I need to add, how about 225? Minus 12 plus 225 is 213. So 225 is my value for k. That is my translation, up 225. Next one, slopes are the same. G of x is f of x plus or minus something. I got to get from 305 to negative 11. I've got to subtract 305 and subtract 11 more, so I have to subtract 316. G of x equals f of x minus 316. I actually wanted to check that answer real quick. I don't remember that. Yep, that's correct. Okay, here's another form that you might get this in, is in a table. If I have a translation, g of x is f of x plus or minus some number, it really doesn't matter what the value of x is, or even the value of f of x. If you think about these on a graph, slopes are always the same. The only difference is some spacing in the y direction. So it's really only the y-intercept that's changing. The spacing in the y direction is going to be the same everywhere along the line. So all I need to do is look to see, how do I get from f of x to g of x? I'm going to, in this case, let's see, add 15. Let's see if it works again. Add 15. 46 plus 15 is 61. That works. Add 15. Let's check it. 121 plus 136. Excuse me, 121 plus 15 is 136. That works. Plus 15 here. That works. I probably wouldn't need to check all 4 of them, but I'd probably want to check 3 of them. Alright, let's do the next one. We can use that same procedure. G of x equals f of x adjusted by how much? To get from 5 to negative 42, I got to subtract 47. See if that works here. Negative 1 minus 47 is negative 48. Negative 13 minus 47 is negative 60, and so forth. There's your translation. Alright, let's finish this off. G of x equals f of x adjusted by how much? Let's see, to get from 4 to negative 15.5 is subtracting 19.5. That works here too. Subtract 19.5, subtract 19.5, and so forth. The very last section here I'm going to have to do on a separate video because I'm running out of time.